Welcome to R Programming for Beginners. Find the link to the full course in this video description. From zero knowledge to data hero and 7 case studies. I'm Stephen McDaniel with Yak Data. Thanks for joining me. Let's take a look at the roadmap. We're going to go through an introduction to the world of R, install R, RStudio, and many of the top R packages for data science. Case study 1 is the basics of R and RStudio usage. Case study 2, data analysis. Intermission with the value of R in analytics and visualization, understanding how R compares with other alternatives. Case study 3, data tables. Case study 4, line and area charts. Case study 5, presenting data in maps, interactive maps. Case study 6, bar charts, scatter charts, and box plots. And we'll wrap everything up with case study 7, bringing it all together in a dynamic, shiny web app using content from the prior case studies. What is R? Well, it's a diverse yet integrated system that includes data access, data collection, and data management packages and capabilities. Statistics from traditional to newer techniques, such as forecasting, data mining, machine learning, and text mining. Graphics, both static and interactive approaches. Here we're going to emphasize interactive graphics suitable for presentation quality for executive presentation or building shiny web apps. And so much more, with over 19,000 packages now available for our users. So, R is both a programming language and a compute engine. So, it can be a little bit confusing if you're new to R when people talk about R running things or writing R code. They're interchangeable terms, and it's the programming language that runs on the R compute engine is a simple way to think of it. So, R is a language where you have commands. This is the simplest form of R usage, typed into a command line interface and executed by the computing engine. You get dynamic results returned to you, the user. And there's a wide range of formats to share data, status, information, lots of things like functions, data frames, vectors, matrices, time series for data formats, database connections, text listings, all types of output such as HTML, PDFs, images, shiny web app, which we'll do in case study 7. So, where did R come from? First, you should know, of course, it's open source, which you probably already knew that. But you might not know it was based on a programming language called S, developed in Bell Labs in New Jersey in 1976. So its origins are quite old. Bell Labs, if you're not familiar, was part of AT&T, and it was their research arm. Originally, R was developed at the University of Auckland in New Zealand, so 1993, so it's almost 30 years old. And it's currently run by the R Foundation in Vienna, Austria, so a nonprofit that controls the direction of R as a development analytic language. Thousands of contributors, individuals, universities, companies, and organizations contribute to R, mostly through packages that you can install, also through the core R system. But the majority of people who contribute to R, my experience and assessment, is primarily through the packages, the 19,000 packages that exist. And here's the open source R logo. So what does the core R programming interface look like? This is not what we're using in this course, but just to give you an idea of what the R console looks like and the default shipping R interface. So here you can see I'm typing in commands and I immediately get a response right below the command. This is the traditional command line interface right in this area. I printed hello R user, sort of a hello world. The next line here in blue, I did a simple data frame called health, and I put in a few values of people's weight relative to their height. And then I ran a correlation, a simple correlation of health $height to health $weight. And you'll see there's a very high correlation in this example. So another example of what I could have done is up here I could have typed in plot health.height, health $height and health $weight. So plotting these two against each other, X and Y, health $height, health $weight. This is the crude basic graphics that ship with default R. This is not the type of graphics we'll be doing in this course, but it gives you an idea of like what the core R system is. As we said, it's quite old. The packages are where all the modernized versions of a lot of things are. The official source for R is https cran.r-project.org. So CARN, we'll talk about that in a second, but this is where you can download the core R programming language and engine if you prefer. This is not the way we're going to install it in this course. We have a much simpler way to manage it and efficiently use it, and also to ensure you get the same results I get in the course. If you were to install that, you get the basic data management facilities, primitive programmer-oriented data analysis tools, a variety of statistical functions, basic graphing capabilities, and there's 6 packages that are part of the standard R install: stats, graphics, utils, datasets, methods, and base. I'm just letting you know that there's packages by default that install with the core R. Those are ones that you don't have to install if you were to go this traditional route of installing R. And then there's lots of packages we'll have in this course that are beyond that are, again, modern versions of many of the capabilities in the core packages. So what is an R package? I would call it a way to expand the core R functionality. Typically, an R package is a collection of related functions in R. And some R packages are different variations, such as a collection of data files for a specific topic or domain, specialized group of files, and an R package may contain code samples that demonstrate vital functionality of the package, sample data files, which might go with the code samples, and ideally, almost all packages have help and documentation files. So where can you find R packages? Well, anyone can create them, but any package which extends the capability of R is officially released on CRAN. It will undergo a rudimentary review process. Now, the review that a package undergoes on CRAN is a basic review for basic test. It is not a guarantee that all things are hunky-dory in the package. So it's some basic QC test, and that it will fit into the CRAN ecosystem and not be disruptive to other packages. But it is not a guarantee of quality control. So you want to be careful about which packages you use, who's developed them, how many releases have occurred, how well documented are they, is there a lot of users using them when you go look at the forums, things like that. CRAN is used as the default install source for packages in RStudio. That's what we'll be using today for our R programming interface. And again, there's almost 19,000 packages on CRAN as of today. Likewise, there are other packages not on CRAN that might be of interest to you for special topics, either in beta or unofficial packages that they just haven't gone to the trouble of releasing them on CRAN because they're more niche. Check out GitHub. So there's a lot of packages on GitHub. In fact, many of the highly used packages on CRAN are also on GitHub. So if you want to install packages from GitHub, you have to issue a special install command. It's typically documented on the GitHub repository. Also, you can build your own packages locally for your own use, which is beyond the scope of this course. If you'd like to find packages by subject area, check out CRAN Task Views. Finally, once you install packages, where are they on your computer? Well, they're organized into something called a library, which is a directory with all the packages you've installed organized at a subdirectory level. So we have R, we have packages, and we have functions. Let's talk about the differences between these. So code in R is solving a specific problem. So your business or research problem, you're writing code. Everyone writes code, including new users. So no matter how new you are, that's probably one of the first things you'll do is start writing code in R. A function solves a general problem. So intermediate users, once you're a little bit familiar, it doesn't take very long, you can start writing functions. Why? Reusable code snippets. You want to save time and improve your code quality and reproducibility. Well, a package is typically a collection of functions for a general subject area. Typically, these are created by expert users or a group of expert users solving a broad class of a problem. And if they are published, anyone can use them, of course. So again, that's just distinguishing between writing code or an R program versus functions, which can be in your R program or called from packages, and then packages. Again, code uses functions, typically from packages in R, and sometimes from user creation, whether in the program or from a general purpose library that they call themselves. So, a few words on R. R is very broad, very deep. There's so many topics in R. You could be thinking about forecasting, you could be thinking about just being a core R programmer and data access and maybe shiny web apps, all kinds of permutations, people from all disciplines, millions of users around the world. So it's a very broad language, especially when you come to the packages. So we're going to cover a lot in this course. You may need to repeat especially the earlier sections for it all to click if you're new to programming in particular or to R. Don't be upset, this is typical. Practice makes perfect, especially with analytics and data science. Nothing really makes it stick like doing the examples a few times and finding a few other examples that are interesting to you. So we're providing an introduction to how R works, right? So it's inspiration and ideas of what you can accomplish at work. And of course, your background and skill levels of the people taking this are very diverse. You could be a hardcore programmer from other languages. You want to pick up R for a variety of reasons. A statistician, you want to pick up R, you haven't used it yet. You could be a business analyst, a regular business user who wants to start doing some kind of analytic work as part of your daily workflow. All kinds of people are here. So don't worry about every detail. R is complex. There are lots of possibilities, lots of paths. But you will have the tools, which we'll do in the next section, and we have the solutions posted so you can practice and look at the solutions and learn through doing and reviewing later, so don't worry about that. The goal of the first couple of case studies is stay on course and understand the essentials. Well, thanks for joining me. Subscribe to this channel, like this video, add your comments. Wow, so who knew R was so big? Take a quick break. Next up, we will install R, RStudio, and more.